And let's use a partial fractions decomposition for this integrating this rational function. Notice that our denominator is factored for us already, so we don't have to factor the denominator. The z squared plus 4 will not factor any further because there are no zeros. It's a parabola that opens up above the x-axis. So this is as factored as it gets. So we'll start by writing out the decomposition. The first term is a z. Since it's a linear term, the numerator will be a constant, a. The second term is z squared plus 4. Since it's a quadratic term, the numerator will be a generic looking linear term, bx plus c. We apply our standard process, clear out the denominators by multiplying by this entire denominator over here. That leaves me with a z plus 1. The z will cancel here, and that leaves with a z squared plus 4. And the z squared plus 4 cancels, leaving me with bx plus c. Sorry, this should be a z. bz plus c multiplied by z. We choose good values for the variable z. Z equals 0 will be nice because it will make that entire thing go away. If I let z equal 0, I get 1 is equal to 4a plus 0. This is 0, but this is 0, and this is 0, so that a is 1/4. Let me write that up there and save it. There's no other good choices for z. Nothing else will make anything 0. So we're going to just pick any other numbers. Let's start with just z equals 1. That's my next favorite choice. Z is 1. This becomes 2 is equal to 5 times a. So that's a, but a is 1/4. So that's 1/4 times 5 plus b times 1 plus c times 1. So that's b plus c. So that's 2 is equal to 5 over 4 plus b plus c. So we can turn that into a simpler equation. If I multiply everything by 4, I get 8 is equal to 5 plus 4b plus 4c. And we're going to save this piece as well. I'm going to bring the 5 over to the left, and we see that 4b plus 4c is equal to 3. As we've seen in some previous examples, we'll need to choose another value for z, which will get us another equation with b and c, and we'll be able to use those to find b and c. So we don't need any of this. We'll choose one other value for z. How about z is equal to -1? If z is equal to -1, this becomes 0. This is still 5a, and a is still 1/4. Plus, now that's negative b plus c times -1. So that's 5 over 4, bring it to the left is -5 over 4, and distribute the -1 makes b minus c. Multiply through by 4 makes -5 is equal to 4b minus 4c. So 4b minus 4c is -5. Now we have two equations and two unknowns, b and c. So we'll solve for b and c. We've already got a right here. If I take this top equation, I get 4b is equal to 3 minus 4c. And I can plug that right into 4b right here. So that's 3 minus 4c minus 4c is -5. So that's -8c, and bringing that over to the other side also makes -8, so that c is equal to 1. And if c is equal to 1, I can plug it in right up here and find that 4b is 3 minus 4c, which is 3 minus 4, is -1. So that b is equal to -1/4. And I've got my A, I've got my B, I got my C. And so we can substitute those into the decomposition. Finding that we will get integral of A, which is 1/4 over Z, plus BZ plus C. BZ is negative 1/4 X, or Z, that should be a Z, Z plus C, which is 1, all over Z squared plus 4. dz. And so we started with this. We applied our partial fractions decomposition, breaking it up as we see here. We calculated A, B, and C, and we've made our way down to this step. So I'm going to rewrite that up here so I have some more space to work. This is all we've got to worry about right now. Everything else was just leading up to this. So that was integral of 1/4 over Z plus negative 1/4 Z plus 1 over Z squared plus 4 dz. At this point, that's what we're trying to integrate. This first piece, so we're going to break that up into two separate integrals. The first piece is then written as 1/4 1 over Z, dz. And then I'm actually going to break this piece up. We've seen something like this in the past. It's a little trick, an algebra trick that we have to use in order to get to a solution. For this one, I'm going to break this one up into negative 1/4 Z over Z squared plus 4 plus 1 over Z squared plus 4. Right, so all that I did was keep this denominator and then separate the denominator out with each of the pieces of the numerator. And if this is a common denominator, so I can add them back up, and I would get exactly what we started with up here. Okay, so this is 1/4. 1 over Z integrates to ln absolute value of Z. That part is good. I can bring the 1/4 out front here as well. So that's negative 1/4. Integral of Z over Z squared plus 4 dz plus integral of 1 over Z squared plus 4 dz. And now we've already got this one done, so we have two other sub pieces that we've got to integrate down below. This one will be and we'll see that we have to use a different method for each. If I just gave you Z over Z squared plus 4, that's something that you actually could have done way back when. This is a U substitution. If U is the denominator, then du is 2z dz. I have z dz, so we're going to put a 2 in, and we're going to take a 2 out from our process for applying the U substitution. So that the numerator now becomes du, and the integral is negative 1/8 integral of du over the denominator, which is u. Z squared plus 4 is u, so this denominator is just u. Which is negative 1/8 ln absolute value of u, but u is Z squared plus 4. So that's ln of Z squared plus 4. And so that's great. That's actually exactly what we needed it to be. We figured out that entire piece. At this point I can say it's 1/4 ln of absolute value of Z minus 1/8 ln of absolute value of Z squared plus 4. And we're still left with the final piece over here. We've got this piece, we've got this piece, we still need the third piece over here. Okay, I need a little bit more space to work that, so what we're trying to do is to integrate 1 over Z squared plus 4 dz, and I'll come back and get to the final answer. But that's what we're looking at this point, so let me do that over here. This is actually a trig substitution. it's interesting that we start out with a rational function, we apply partial fractions decomposition, and then we have to do three different things in the end. One is just a straight integration, 1 over z. One is a u substitution, but this is trig. This should remind you of tan inverse, except for we have this 4 that's different than the 1. If I have 1 over z squared plus 1, that's tan inverse. So remember what we have to do in this case. We need to have a 4 here so that we can factor a 4 out. I want z squared to be 4 tan squared theta. So that z squared plus 4 is 4 tan squared theta plus 4, which is 4 times tan squared theta plus 1, which is 4 times secant squared theta, because tan squared theta plus 1 is secant squared. Z is then the square root of that, which is 2 tan theta, and dz is the derivative of that, which will be 2 secant squared theta, d theta. Substituting everything into the integral gives me 1 over z squared plus 4, which is right here, which is 4 secant squared theta, and dz is right here, which is 2 secant squared theta, d theta. Secant squareds cancel, and we're left with 2 over 4, which is 1/2. So this is 1/2 integral of d theta, which is 1/2 theta. Finally, what is theta? Well, if z is equal to 2 tan theta, divide by 2, I get z over 2. Take tan inverse, I get theta is tan inverse of z over 2. And that's our final result. So that will be 1/2 tan inverse z over 2. So that's this piece right here. Plus c, and then we're done.